So today we're going to start our first section in our trigonometry unit. and this introduction to trigonometry starts with angles, that we're going to be talking about triangles, and then later on the ratios of the sides of those triangles and how those ratios will form the sine and cosine curves, all of our trig ratios and their curves. It's actually a pretty interesting study, and it's kind of like starting back over at square one. So if you were a little overwhelmed by the last unit, then we're actually starting back at square one, and this is going to be new for everyone, and so we'll treat it that way. So just keep up with each lesson, and they'll build on themselves, and we should be fine. So our first topic is going to be about angles, and we're going to talk about how to measure an angle in standard position. So an angle is in standard position if these things are happening. If its vertex is at the origin, over here, and its initial side is on the positive x-axis. So it starts here on the positive x-axis. Okay. Now, once we've started there, we're going to measure these angles going in a counterclockwise rotation. A counterclockwise rotation is a positive angle, and that angle we're going to refer to most of the time as theta. It could just be x, but in our trigonometry, we're usually going to call that unknown value, that unknown angle, theta. And if I were to go in the opposite direction, like the direction of the clock, the angle that I get is a negative angle. A clockwise rotation is a negative angle. Now, this rotation can be measured in degrees or in radians. Degrees are something that you're probably familiar with. You know that 180 degrees means you're turning around 180 degrees, 360 degrees, full circle, turning all the way around. But we're probably not as familiar with radian measure. So we're going to talk about radians just a little bit today. It's kind of like measuring something in inches and in centimeters. Both of those are units of measure for length, just different types of measurements. And that's kind of like degrees and radians. They're just two different types of measurements for the same thing. So let's talk about a radian. A radian of an angle is its arc length divided by the radius. Arc length divided by the radius. And if you look in this picture over here, arc length is the length of the intercepted arc of the circle that this angle goes through. So when we draw in our circle, with this being at the origin, the length of the arc, the actual measurement of the arc, divided by the radius is going to give us our angle theta. So when we look at this picture, theta, our angle, is just 3 divided by 2, 3 over 2. Now, here's where the radians come in. So in this picture, if S and R are exactly the same length, so if I were to take a string and kind of lay it out on this arc and then straighten it out, and it's exactly the same length as R. So if S is equal to R, then we would get 1 radian. So theta is 1 radian in this situation. So here it is, the measure of a central angle that has an arc that is exactly the same as the radius. So if you look at this picture, I mean, we're gonna estimate here, but straight across, halfway around the circle. It looks like you could fit about 3 of these in here. And then, straight across again. Looks like there'd be about 3 more of those, maybe about 6 total. About 6 total radians in that circle. Now that was just an estimate. I mean, we were just kind of eyeballing it. There's 1, 2, 3, 4, 5, 6. So remember that a radian is just another unit of measure. 360 degrees takes us all the way around the circle, and it looks like about 6 radians would take us all the way around the circle. So on the back, we're going to continue that comparison of degrees to radians. So we know that 360 degrees is all the way around the circle. And if I go all the way around the circle, then my arc length, the arc length here, is actually equal to the circumference, because the circumference is the distance all the way around the circle. Oh, you can see what I was right. Arc length is equivalent to the circumference if I go all the way around. So when it says arc length for 360 degrees, that would be 2 pi r, which is the circumference formula. And we know that a radian is the arc length divided by the radius. So here it's 2 pi r divided by r. So we just get 2 pi radians. So it looks like 360 degrees is equivalent to 2 pi radians. So let's tie that back into our estimate a minute ago. We know that pi is 3.14, so we're saying 2 times 3.14, which is approximately 6 radians. So it matches the picture that we talked about on the other side as well. Now, if I want to find a way to convert from degrees to radians or radians to degrees, kind of like we convert from inches to centimeters and centimeters to inches, we need some kind of comparison. So we know now that 360 degrees equals 2 pi radians. So if I want to know what 1 degree is, I could divide both sides here by 360, and I would get that 1 degree equals 2 pi over 360. That'll reduce to pi over 180 radians. So for every degree, I would multiply by pi over 180, and it would convert it to radians. So whenever we want to go from degrees to radians, we're going to multiply by pi over 180. And with that same ratio, 360 degrees is equal to 2 pi. If I wanted to convert from radians to degrees, I divide by 2 pi. So 1 radian would equal 360 over 2 pi is 180 over pi degrees. So if I want to switch from radians to degrees, I need to multiply by 180 over pi. So if you didn't follow all of this, then this table, this chart right here, is what you're going to need to know to be able to convert from degrees to radians and radians to degrees. So let's take a look at these problems down here. We want to convert degrees to radians here. So we're going to take negative 225, and we're going to multiply by pi over 180. So I get negative 225 pi over 180. And that is in radians now. But we also know that we could reduce that. So if you're not great at reducing fractions on your own, which here we could start dividing by 5 and then divide again. I'm going to show you on the calculator really quick how you could do that. Alright, if you will take just the numerical part without pi, we're going to keep that pi symbol in here. So just take the negative 225 divided by 180. We get a decimal. We don't want to use the decimal. We want it in fraction form. Move that so you can see it. So we get negative 1.25. If you go right down here on the TI to the math key, math, and then number 1, we'll convert it back to a fraction, hit enter. We get negative 5/4. So this is equivalent to negative 5 pi fourths. If we want to convert 315, we do 315 degrees times pi over 180. We get 315 pi over 180. And again, you could reduce it yourself, or on here you could do 315 divided by 180, and then hit math frac, and it changes it to 7 fourths. 7 pi fourths. All right, and if we want to convert from radians to degrees, we're going to multiply by 180 over pi. So negative pi thirds times 180 over pi. As long as that pi symbol has been left in the radian measurement, we can just reduce it out. We have negative 180 divided by 3, which is negative 60 degrees. All right, same with the next one. 3 pi fourths times 180 over pi. The pi's will divide out. So I multiply. 3 times 180 is 540. Divided by 4 is 135 degrees. All right, so this is going to be very important for the rest of our year. In our study of trigonometry, you need to be able to convert from degrees to radians and radians to degrees. So pi over 180 or 180 over pi. All right. Next, we're going to talk about the quadrant. See that word quadrant in here? Quadrant angles, quadrantal angles. And so I'm going to make a sketch here of some of those angles. So our quadrants on the unit circle, we have quadrant 1, 2, 3, and 4. And so the quadrant angles are the angles that land on one of these lines for a quadrant. So I could go from here to here for my angle, or I could go from my initial side over here as the terminal side, or I could go down here down to here for my terminal side, or I could go all the way around for the terminal side. So my angle could be any of these and be considered a quadrantal angle. So for this first one, I didn't go anywhere. It's just out here. The line itself is just 0 degrees. For this one, I went all the way around the circle in a counterclockwise direction. This would be 360 degrees. And it says that it wants us to name these in degrees and radians. Well, we already know that 360 degrees is equal to 2 pi radians. That's what we use for our conversion up there. So I'm going to back up to this one. We know that this is 180 degrees. All right, half of 360 or 180 degrees. So half of 2 pi would make this pi radians. Okay? And then I know that this is 90 degrees. Half of 180 is 90 degrees. And if I were to take half of pi, I would get pi halves. So this would be pi halves radians. All right, and then I kind of saved the hardest one for last. We know that this is 180 plus 90, or 270 degrees. So 270 degrees would be 1 pi plus another half, right? 1 1/2. But instead of putting 1 1/2, we know that 1 1/2 is equal to 3 halves, right? So I'm going to call this one 3 pi halves. So we've got 0 degrees is 0 radians. 90 degrees is pi halves radians. 180 degrees pi radians. 270, 3 pi halves, 362 pi. All right, so now we're just going to do some sketches. The sketches in degrees are going to be fairly easy because I know you're pretty used to thinking in degrees. So these sketches don't have to be exact, but we kind of want to put them in the right place, and they definitely have to be in the correct quadrant. So 120 degrees, well, if I start with my initial side here, and I'm supposed to go counterclockwise, then when I get to the top, I'm only to 90. So 90 plus 30 degrees would put me right in here. I'm going to draw my terminal side, initial side, terminal side, and then I want to label my angle. So I'm going to show the direction and label the measure. So a negative 120 degrees. Well, we still have to start here for our initial side, but this time we're going counterclockwise or clockwise, which means we have a negative angle, so negative 90 plus 30 more. We're going back this way. That's negative 120 degrees. So all of those things, whenever you do your homework and you're trying to label the angles, I need you to mark the initial side, the terminal side, the direction, and the measurement. Initial side, terminal side, direction, and measurement. All right, so this last one is in radian measure, and you certainly are welcome to convert this back to degrees if you think better in degrees, but it will be a time saver if you can go ahead and start trying to think in radians. So let's use what we've just learned about radians for our quadrant angles here to see if we can help us out. We know that pi halves is 90 degrees. Well, a fourth is a half of a half. So a fourth would put me halfway in between. A fourth of pi would put me right in the middle there. Pi fourths radians. Now, like I said, if you want to convert it, you could do pi fourths times 180 over pi. You're going to get 180 over 4, which is 45 degrees. So obviously that's a 45-degree angle. It's halfway across. Now if I want to go negative pi fourths, I can go back the opposite direction, initial side, go this direction, 45 degrees down, or negative pi fourths radians. Okay, so you're going to be making sketches on your homework, both in degrees and in radians. So for example, if I ask you to draw 3 pi fourths radians, 3 fourths would put us in here because 1 is all the way to 180. A half is up here. 3 fourths would be halfway in between. So if you can start thinking about those fractions in your radian measurements, it's sure going to help you so you don't have to convert everything. All right. That is lesson 1 in trigonometry.